There's a gene inside every store-bought tomato that was quietly switched off before most of us were born. Not by accident, purpose, and once it was gone, flavor stopped being a priority in commercial farming. Almost nobody noticed for decades. You've probably assumed homegrown vegetables taste better, simply because they're fresher. That's what the produce industry is comfortable with you believing. But freshness is only a small part of the story. The real reasons go much deeper. Or into genetics, into what cold storage does to DNA, and into something living beneath your soil that commercial farming has been quietly dismantling for years. 3 forces, all working together, all hidden in plain sight. And by the end of this video, you'll never look at a grocery store tomato the same way again. If you grow your own food, or you've always felt like store-bought vegetables just don't taste right anymore, hit subscribe. This channel is built for gardeners who want real answers. Now let's get into it. It starts with a discovery made before 1930. A tomato grower somewhere in the United States noticed something unusual on one of his plants, a tomato that ripened perfectly evenly. No dark green patch around the stem, just clean, smooth, uniform red, from top to bottom. To a farmer, that looked like a premium product. To a grocery store, it looked like a gold mine. By 1930, the first commercial variety carrying that trait was officially released. They called it All Red. And within a few decades, nearly every commercial tomato grown in America carried that same mutation. It became the industry standard. Now, here's where the story takes its first turn, because scientists later went back and looked closely at that green patch they had bred away, and what they found was shocking. That dark green ring around the stem was not a defect. It wasn't an eyesore. It was actually the sweetest, most flavor-active part of the fruit. Here's why. That green color came from chloroplasts, tiny structures inside the fruit tissue itself that were capturing sunlight and converting it directly into sugar. The tomato wasn't just being fed by its leaves. It was photosynthesizing from inside its own skin. Scientists measured that this process contributed up to 20% of the tomato's total sugar content. 20%, just from that patch they decided looked ugly. The gene responsible for building those chloroplasts, old LGLK2. When breeders selected for uniform color, they disabled that gene entirely. No gene, no chloroplasts in the fruit, no fruit photosynthesis. Yeah, and with that, sugar levels dropped, orotenoids dropped, flavor dropped. The tomato looked better on the shelf. It tasted like almost nothing in your mouth. And here's the part that should bother every one of us. This was not an accident. This was a trade, visual uniformity, in exchange for flavor. For nearly a century, we've been breeding tomatoes to survive a shipping route, not to impress your taste buds. The consumer never voted on that trade. It was simply made for them, quietly, and locked into almost the entire commercial supply. But the genetics was only the beginning, because once the industry solved the appearance problem, they ran straight into the next one. Tomatoes bruise. They rot. Getting them from a farm in Florida or California to a grocery store in Ohio without turning them into mush meant they needed to stop ripening naturally on the vine. So breeders went back into the genetics. Again, yeah, they found mutations with names like ripening inhibitor and never ripe that interfere with ethylene, the natural chemical signal a fruit produces when it's ready to complete its ripening. Ethylene triggers the final conversion of starches into sugars. It drives the synthesis of aromatic compounds. It softens the flesh. It is, essentially, the signal that tells a tomato, you're done, you're ready, ripen now. By introducing these mutations into commercial varieties, breeders could freeze the tomato mid-development, firm enough to survive the truck, intact enough to reach the warehouse. Then, once it arrived, workers would load those green tomatoes into sealed chambers and flood them with ethylene gas, forcing the color change on command. The tomato turns red. It looks ripe. It goes on the shelf. But it never finished what it started on the vine. The sugar conversion, interrupted, the aromatic compounds, never fully developed. What you are buying at the grocery store is not a ripe tomato. It is a tomato that was told to look like one. But here's the twist. Even after all of that, the disabled gene, the early harvest, the ethylene chamber, there is still one more layer of damage, one that researchers only confirmed in 2016. And when I tell you what it is, you'll understand why leaving your grocery store tomato on the counter for a few days does absolutely nothing. The moment commercial tomatoes are harvested, they enter what the industry calls the cold chain. To prevent decay during weeks of transport, vegetables are held below 54 degrees Fahrenheit. Standard refrigeration. Sounds harmless, but here's what that cold is actually doing inside the fruit. Chilling tomatoes below that temperature doesn't just slow down decay, it triggers a biological response. Inside the fruit's own cells, the cold causes chemical markers to attach directly onto specific genes, essentially switching them off. At the molecular level, the genes being silenced are the master regulators of flavor synthesis. When they go quiet, everything downstream goes quiet with them. The enzymes that produce the volatile compounds, responsible for real tomato aroma, the green, grassy notes, the fruity depth, the floral undertones, stop being manufactured. And now, here is the part that changes everything. When researchers took those cold stored tomatoes and brought them back up to room temperature, exactly the way you do when you bring groceries home, the flavor genes did not recover. The damage was not temporary. Several of the critical flavor enzymes remained permanently suppressed. The flavor wasn't lost at the store. It wasn't lost on your counter. It was destroyed in the refrigerator truck, and no amount of waiting brings it back. Think about that for a moment. Every time you've left a grocery store tomato on the counter, hoping it would ripen and taste better, you were trying to recover something that was already gone. The homegrown tomato bypasses all of this entirely. You harvest when the fruit is ready. It completes its full cycle on the vine, and then you walk it straight into your kitchen. No cold chain, no ethylene chamber, no silenced flavor genes. The full biological expression of the plant, unbroken. But there is a third layer to this story, and this one is underground. In a world most gardeners have never thought about, but one that may be the most powerful factor of all. Beneath healthy, undisturbed soil, there is a living network, a web of microscopic fungal threads, called mycorrhizal fungi. These fungi form a direct partnership with the roots of over 80% of all plant species, including tomatoes, peppers, and most vegetables you'd grow in a home garden. They attach to the root system and extend outward into the surrounding soil, sometimes reaching 3 inches beyond, where the roots themselves can go. Think of them as a second root system. The plant didn't have to build itself. Through this network, plants gain access to phosphorus, calcium, and magnesium, minerals their own roots could never reach in sufficient quantities. In exchange, the plant feeds the fungi, transferring up to 20% of its energy directly into that underground partnership. It is one of the oldest biological relationships on Earth, hundreds of millions of years in the making, and commercial farming has been quietly dismantling it with 3 standard practices. First, mechanical tillage. Every time that soil gets turned before planting, the delicate fungal threads are shredded, the network collapses. Second, chemical fumigation. Used widely in commercial fields before planting, it sterilizes the soil completely. Every living organism, including the entire fungal population, eliminated. Third, and this one nobody expects, high phosphorus synthetic fertilizers. When a plant detects abundant soluble phosphorus already available in the soil, it actively shuts down its own fungal colonization. It decides it doesn't need the partnership anymore, so the fungi retreat, and the plant loses access to the full mineral spectrum that only a living soil ecosystem can provide. Here's why that destroys flavor. Calcium, magnesium, and potassium are not just nutrients for growth. They are the cofactors, the essential working parts of the enzyme systems that build flavor compounds, the volatile molecules, the terpenes, the aromatic depth that makes a vegetable taste like something. When those minerals are consistently deficient, those flavor pathways run at a fraction of their capacity. If plant grows, it produces fruit, but the richness inside that fruit is a shadow of what it could be. This is why two tomatoes, grown from identical seeds, same variety, same genetics, can taste dramatically different, depending on where they were grown. The genetics didn't change. The soil biology did. In a home garden, where the soil rarely gets deep tillage, where compost replaces synthetic fertilizers, where the same beds are used season after season, the mycorrhizal network has the chance to establish and persist. The soil becomes a living system, and the plants rooted into that system have access to everything their flavor pathways require. So let's bring all three together. Commercial tomatoes carry a genetic mutation from before 1930 that disabled the fruit's ability to photosynthesize its own sugars, reducing potential sweetness by up to 20%. They are harvested before ripening is complete, forced to redden with ethylene gas, then held in refrigerated transport that permanently silences the genes responsible for aroma. And they are grown in soils where decades of tillage, fumigation, and synthetic fertilization have collapsed the fungal networks the plant depends on for mineral-driven flavor complexity. Three systems, all compromised, all by design. Homegrown vegetables, grown from heirloom or open-pollinated varieties, harvested at true maturity, never chilled in a transport truck, rooted in living, undisturbed soil, carry none of those compromises. The flavor difference you taste is not nostalgia. It is not imagination. It is the measurable result of three biological systems running at full capacity instead of being dismantled one by one. And every single one of these factors is within your control. Choose heirloom or open-pollinated varieties. Let your vegetables ripen fully on the plant. Avoid unnecessary tilling. Feed your soil with compost rather than high-phosphorus synthetic fertilizers. Let the biology beneath your feet do what it has been doing for millions of years. For decades we've been told that flavor disappeared because modern life demands convenience. That's only half the truth. Flavor disappeared because, step by step, we engineered it away. The remarkable part, your backyard, can still grow food the way nature intended, and no commercial supply chain, design, can replicate what you grow, right outside your door. If this video changed how you think about the food you grow or buy, want to turn to all filled, it helps this reach more gardeners who need to hear it. Drop a comment below and tell me which of these three things surprised you most. The genetics, or what's happening beneath your soil. And if you haven't subscribed yet, this is exactly what we do here. Real science, made useful for real gardeners.